Hey guys, let's start looking at lesson 6.2. We're now starting to look at some exponent rules. So if you remember, exponents are those tiny little numbers up above what we would say are normal numbers or letters. For example, anything squared or cubed. That 2 that makes it squared is an exponent. So we're looking at learning some rules, and today we're going to focus on the rules called product of powers and power of a power. Basically, what we're going to be doing is simplifying expressions that have exponents in them and that require us to do things with exponents. So if you're successful with this lesson, we can tell the difference between power of a power and when we should use product of powers, and then be able to apply both of those rules in grouping like terms and then simplifying. This is just another step from what we were looking at in lesson 6.1. What's great about this lesson and all of my exponent rules is that they are given to me on my Algebra 1 reference material. That means I don't have to remember the rule. I just have to remember how to apply it. So let's look at these two rules. The first one, like I said, is product of powers. Okay, and product of powers looks like what we see over here on the right. When you have a number that is raised to a power, and then you have the same number raised to a different power, or the same, you add the exponents together, and you can use the same, what we call base number. So that A would be our base number. So if you have the same base number, you can add the exponents together if they're being multiplied. So let's look at this. This is when you are going to add exponents. So if you are multiplying a number with an exponent times that same number to an exponent, you can add the exponents and it'll be the same thing. That is what that rule tells us. For example, if we have, let's do 2 to the 4th power times 2 to the 6th power. Since I'm multiplying those, they have the same base of 2. I can add my exponents, so it ends up looking at 2 to the 4 plus 6 power, which is 2 to the 10th power. Those are going to be the exact same thing. Now, my other rule is called power of a power, and that is when we're going to multiply exponents. And what that looks like is when we have something that's raised to a power and then it's raised to another power. So if we have, let's say 2 to the 4th power, and then that is raised to the 6th power, then you're going to multiply the exponents together. So this would be 2 to the 4 times 6 power times 6 power, which would be 2 to the 24th power. So when you see a power of a power, so an exponent that's raised to another exponent, you're going to multiply your exponents together. And when you see 2 exponents with the same base multiplied times each other, you're going to add the exponents together. Those are the rules. So if you can see them and understand what they mean, then you are going to be successful in that. So let's look at identifying the property. Let's see if we can identify when we should use which rule. So when we have x squared, x fifth, there's nothing in between them, that's multiplication. Right? If there's nothing in between them, it's actually being multiplied. It doesn't have to necessarily have a multiplication symbol or that dot or parentheses. If you have letters next to each other, it's being multiplied. So we're going to use our product of power rules, which means we're going to end up adding my exponents. But right now we're just saying, okay, this is when you would use the product rule. And I would use this, when we finish this, as sort of a key to help us in our practice. Okay, this next one below it says 4x to the negative 5th power times x times y to the third power. Okay, right there I see a multiplication symbol, so that is also going to be a product rule. Okay, this last one right here has some parentheses, and it looks like we are doing a little bit of both. It looks like here in this first little section, I'm doing a power of a power, and then it looks like I'm doing another power of a power, but then it looks like in the end, I'm also going to use my product of powers rule because we're going to multiply them together. So I would say this one is both, but we use power of a power rule first. This top one over here on the right is a power rule because as you can see, we have an exponent on the outside to two other exponents on the inside. That's going to be my power of a power rule. Okay, here I have t squared times x cubed. And then that whole thing times tx to the fourth power. So that is going to be a product rule because we are just multiplying. That is how you show multiplication. And then this last one is a power because there's a power to a power. All right, so like I said, you should use this as a little bit of a key to help you when you are looking at your practice. Okay, but, whoa. But just, by the way, anything to the power of 0, it's equal to 1. Always, always, always. Anytime you ever see anything to the power of 0, it is going to equal 1. So 32,451 to the power of 0 is equal to 1. X to the power of the 0 is also equal to 1. Okay, now let's look at some examples. Start with example 1. We have 4n to the 4th power times 2n to the 8th power. When we're looking at simplifying expressions, we still multiply those coefficients just like we would as normal. So the coefficients, remember, being the number in front of the letter. So I'm going to multiply 4 times 2 and get 8. Now with my n's, they have the same base, right? They're both n's to different powers. I can use my product of power rule, which tells me that when I am multiplying any number to two exponents, I can add the exponents together. So I'm going to say it's going to be 8 which is just, let's go ahead and write that, which is 4 times 2. And then n to the 4th times n to the 8th. Okay, what I did there kind of was just put my coefficients together so that I could know that I was multiplying them, right? Like I said, that gives us 8, and then we can put it together where I'm going to be adding those exponents together, and then I can just go ahead and add them where I get 8 times n to the 12th, or 8n to the 12th power. Let's try another one from example 2. Okay, 2 has a power to a power because there is a power or an exponent outside of the parentheses saying to raise everything inside the parentheses to the 5th power. So that means I have to raise literally every single thing inside the parentheses to that power, which includes the 2 and then the h to the 7th. So I'm going to rewrite this how I would kind of distribute, if you will, that exponent. It's going to apply to the 2 and to the h to the 7th. So I will have 2 to the 5th times h to the 7th. And when I have a product or a power of power rules, when I have an exponent raised to another exponent, I multiply my exponents. So it's actually going to be 7 times 5. Now let's go ahead and simplify. 2 to the 5th power is 32, and then times h, 7 times 5 is to the 35th power. Let's look at 2 more examples here. Okay, this one is a little bit more complex. It looks like we have some power of a power and product of powers. So the first thing I notice is that I have a 3 on the outside of my parentheses telling me to cube everything inside the parentheses. And then I also, in my second little section, have a squared outside, which tells me to square everything on the inside. So I'm going to write these two as separate expressions, and then I will come to the end. So I'm going to use my power of a power rule first. And I'm going to focus on this left one right here first. So I need to cube everything in it. So it's going to end up being 2 cubed times W to the 4th times 3rd. Because remember, when it's power of a power, you multiply it. And then times G to the 3rd. Remember, if it doesn't have an exponent with it and it's a letter, that exponent is just 1. But 1 times 3 is going to be 3. So that's why I wrote it like that. And then I'm going to go ahead and put this back in parentheses. And then I'm going to write the second section now. So now we're going to look at this one. And I'm going to start with parentheses. I need to have 4 squared and then times W to the 5 times 2 power. So now let's go ahead and simplify. 2 cubed is 8. Times W to the 12th power, because 4 times 3 is 12, and then G stays cubed, just like that. I'm still going to leave this in parentheses because I haven't multiplied it times that other section. Now let's simplify out the other one. 4 squared is 16 times W to the 10th. Now that I have taken care of my power of a power rule, I'm going to do my product of powers, which requires me to multiply my numbers together. So like I did on that first one, I can rewrite them in an order that makes sense since we're multiplying. So I can kind of put my like terms near each other. So I can have 8 times 16, and I could write it times W to the 12th times W to the 10th, and then put that times G to cubed at the end there. And now all I have to do is simplify. So we're going to do 8 times 16 first. That gives me 128. Now I need to take care of my W's. When I'm multiplying by the same base, which is W, I add the exponents. So it is going to be 128W to the 22nd power. There's nothing to do with the G, so it just goes on right there at the end. That is going to be my final answer. All right, let's look at one last example. This one is fairly similar to that last one in that we have both powers on the outside, but only on one this time. And then we will have to use our product of powers to multiply these two separate expressions. This one times this one, but only after we do that power of a power. So I'm going to go ahead and rewrite by writing my powers. So I should have 2 squared times x to the 4th times 2 times y to the negative 4th times 2 times z to the 3rd times 2. And then all of that will be times multiplied by my second expression there, 3x squared times y to the 8th times z to the 4th power. Now let's go ahead and simplify that left expression so that we can multiply the two together. 2 squared is 4x to the 8th times y to the negative 8th times z to the 6th. All of that's going to be multiplied by that 3x squared, y to the 8th, z to the 4th. I'm going to go ahead and rewrite them next to each other with like terms so that the multiplication gets easier. So we'll have 4 times 3 times x to the 8th times x squared times y to the negative 8th times y to the 8th times z to the 6th times z to the 4th. Okay, now let's go ahead and multiply them out. So 4 times 3 is 12 Remember, when we're multiplying 2 with the same base, we add those exponents, so it's going to be x to the 10th. Because we add 8 plus 2, and then we will have y to the negative 8 plus 8 is 0. And then z to the 6 4 is 10. Okay, and if you look back at that front page, what happens if there's a power of 0? It's just 1, so that y to the 0 becomes 1. And do we need to have a 1 times 1 in there? No, it's not going to change that situation. So we can go ahead and rewrite this equation as 12x to the 10th times z to the 10th. Because y to the 0 power equals 1. Right? Okay, let your teacher know if you have any questions. Good luck, guys.